Why am I here so fast? I found something interesting, so we're just going to continue on this discussion over here. So if I do plus one, let's just say minus one, it gives the same thing. But if I give a plus one over here, just plus one, we get a distortion effect. As you can see, this shows you how selfish I is, our polar form is. Imagine if you increase it to 10 and 10. What happens is that this is what really happens. As you can see, we scaling off from 0. So what happens is that we increased it up to over here. And you can kind of see the R of the rate, the R equal increasing. So the higher we go, the more it should turn to basically a circular shape. So yes, it's very interesting how polar works, and in it basically, if you were to create any single shape and were to increase it to 1,000, 100, who cares, 1,000, infinity, just plus infinity, it will just get a circle, some sort of circle, which makes sense. It just overpowers it all, which makes perfect sense. It just overpowers it all. So yeah, it does make sense as selfish, and I understand why it's selfish now. And you can see that it kind of makes a distorted wave length here. Now, if I put the more interesting one is closer down over here. It feels like a dilation and a contraction, but once you like do a little bit of the higher math, higher if you increase it a little bit, it kind of shows as not distortion because it goes over here instead. Well, when it's low, like just plus two, the this part of the equation overpowers it, making it look like it's just a dilation effect up to here. So what I can say about polar form is that we are actually contracting over here and expanding it over here. Now, is that true for all the positive version? No. As you can see, you're going downwards over here. So there's like a funnel over here like this. And that funnel allows for distortion effects to make a it makes sense kind of. So it's distortion. Polar form can make distortion. I was playing around with numbers, and that is why this effect happened earlier. When we were talking about this, I was curious on what was happening over here with the plus this. When we had this over here, what was happening is that when we have plus this, we just did a plus constant, but the down over here made that plus thing and a variable in between, causing that loop effect over here. So if I did a plus one over here, it should have a similar effect. Yes. But because it's internal, it does create more waves like this because it has an angle shift too. Angle matters in that case a little bit. But if you do a plus one, you can see the basic of the effect. Um, Over here, what was the shape again? This I didn't figure out yet. This shape is interesting. We can try to figure out right now. So what we have here is basically a bottom over here, two over here that's being removed. With that remotion, you created a line basically that goes on pretty much forever. I'm assuming forever. So what's happening here? So this will be always bigger most of the time, except for 0, 0 angle at that point. So what I'm guessing happens is that we're looping like this down to over here because there's a point in the bottom where it gets really small, I guess. And I'm assuming, let me check. I think there's a certain angle then when this is happening. Yeah, there's a certain angle. Not the angle I expected actually. I expected 45 degrees. Ah. Instead, it happens in a weird offshoot. It probably has to do with the ratio of 2 to 2 and a plus over here. The plus would probably blow it up in such a situation when sine is like that. So sine is smallest at 0, so 0 over here. It shows it off as probably as a real number like 2 or something, because this is the only effect that has. It gets bigger to 2. And then when it's pi divided by 2, it also has 0 on the cosine, but that's great because it just cancels out. So it should be just 1 there. And I see. So it has to be one of these angles that makes this happen. And in that process, that makes sense. Yeah. So we're gonna talk. This is like polar distortion, I guess. I get these two equations now. Now this is super interesting to me. So we're just gonna put this in the textbook. I'm making, so we can delete this. Okay. Then we can do control minus this. This is very interesting to me. I can screenshot this. Maybe write something in it. I probably won't, honestly. And then we can put it down over here as distortion. This polar distortion, I guess. Polar distortion, and we put a constant after. Um, Polar destruction. It kind of makes sense, like blowing up from that origin and then spewing out a little bit. It's interesting. I wonder what happens. Is there gonna be the same progress as 3? Oh, that's what's happening. So what's happening is that it's pulling out from. Oh, interesting, interesting, interesting. I didn't think of it that way. I'm wrong with my thought process. So it's pulling out that way. So the first hand is it gives a good impression of what's happening with the +2, but +3 is where is what's happening, really happening with the distortion backwards. Yeah, that is cool. That is very, very interesting. Love the new idea I had. It gives me an impression of what polar could do for mathematical purposes. It just feels a little like a V, like this and this. It's interesting. I must say, I'm quite enthralled by Polar right now. Um, it's very much a distortion event, kind of. Yeah, Polar is interesting as always, but it's not the end all be all of everything. It never was an end all be all. It's just a tool that is very powerful if you know what you're doing. If you don't know what you're doing, then it's like this thing I was doing yesterday. I'm working in Cosmos this summer, so whatever. We're dealing with high school students, and we're basically RAs. I don't know if we had the badge over here, but we're just doing badge work. Yeah, I don't know. Yeah, so yeah, I'm yeah, whatever. Anyway, it's pretty cool, right? I was very amazingly shocked by this a little bit over here. I was trying to figure this out for a long ass time and finally figured it out today. It just took a little bit of what's the word? I don't know. A little bit of a step back, I guess. I have no idea. It's very interesting. It's like a balloon. I wonder what kind of stuff I can do with this. I don't know, but we could definitely try to figure out what the hell we could do with this idea. We could make beautiful shapes, beautiful art, I feel. It would be interesting. Yeah. And then I feel like we could do slider A and then A. Let's see how beautiful this is. Oh yeah. You can feel the beauty of that. That looks beautiful, man. Oh, oh, that looks so beautiful, man. That looks. Yeah, you can kind of see what's happening with this. That looks so beautiful. Oh, the beauty of math, man. You don't understand it until you see something satisfying like this. Oh, man, it's beautiful. God damn it, it's beautiful. Oh my god, I could do this for days. It's incredible that that was the original idea, but we figured out distortion by this. Um, you can kind of see the left and right is different, but yeah, it's beautiful, isn't it? And it looks like there's a range it goes to. It doesn't break off on like a V triangle. And we can test this out by increasing this to 1,000 and then seeing what the range is. Yeah, it doesn't. It seems like there's like if you took a limit of it and it made an equation like a limit toward the infinity point over here to this point, you could probably figure it out. Hold on, let me try a million or something. And maybe it's too much. 1,000 was. Yeah. The thing is, it looks like there's a limit to this. Yeah. And I like it at 10. 10 here is a beautiful subject. When it goes to 100, yeah, I don't know. It feels a little off here. It feels like we're just going to nonsensical areas. Interesting. I don't know what you could do with that. It feels like at a certain point the information is useless. This doesn't look beautiful. But 10 over here to 10, I can see certain uses, like maybe some kind of distortion mathematics follow the system. I have no idea. I was just playing around with numbers, so I have absolutely zero clue if this has any practical use at all. Hopefully it does. I have no idea. Well, if it doesn't, then it doesn't. But yeah, that was a beautiful experience, I must say. Oh God, it's beautiful. Yeah. Anyway, we end this later. Anyway, I'm assuming you could do the same thing with hyperbolic functions. I will probably be doing that next, trying to do the hyperbolic distortion. But I think I'm gonna stop here for now. This was cool.